Let's look at a method called solving by substitution. This is going to be an algebraic way to do the same thing that we've been doing, which is finding the point of intersection of two equations. But the way we've been doing it previously is by putting these two lines on a graph by using the slope and y-intercept. By using the y-intercept and slope and the y-intercept and slope, and then we would see where the lines would intersect. Now that takes a long time, and also what some of you have noticed is that when you try to read the point of intersection, sometimes it's in between the squares, and you have said, should I write 0.5, or can I use decimals? So it's hard to estimate exactly where that point of intersection is sometimes. And what happens if you draw the line a little bit off, and that also affects our point of intersection. And we can call our point of intersection our POI. Some of you have been writing that as well for short, point of intersection. So this method called solving by substitution is going to do the same thing for us. It's going to find the POI, but in an exact way and using only algebra, no sketching, which is good for some of us. Okay, so let's look at what the method is, and we're going to do a couple of examples. Our method is that we take one of the equations and we substitute it into the other. Now, I have this 1 and 2 here. It's very important to label which is equation 1 and which is equation 2, okay? Because we start using them and then it gets confusing. So be very organized. Okay, we're going to take, this is equation 1, and we're going to sub it into equation 2. Now, when I say sub, I mean substitute, okay? So I'm just going to keep saying sub for short. Here's equation 2, okay, and so I want 1 to go into 2, so that means I write equation 2 first, and then I take equation 1 and I substitute it into 2. Now what on earth does that mean? Okay, let's think about this. Equation 1 says y equals something, okay, and then equation 2 also says y equals something. Now I want to take this y, okay, I want to take, this y from equation 1, x minus 2, and put it in place of this y in equation 2. Okay, so notice that's what I did. Here's the x minus 2, and that's from equation 1. There used to be a y here, but instead of writing the y, I took what y equals from the other equation. Okay, now why am I doing that? Well, it's kind of like saying, substituting is kind of like having a substitute teacher. So say I wasn't here today, and Mr. So-and-so came in. So you say, Mr. So-and-so is subbing for Mrs. So-and-so. So that means that, let's say that this is your teacher here, teacher Y, okay? That's saying that this teacher Y is going to come out, and a new teacher Y is going to go in. But this teacher Y is called x minus 2, okay? So Mr. X minus 2 is going to come in place of Mr. Y over here, okay? Because they're both called Y's. They're both teachers, okay? So let's say that again. So substituting means Mr. Y has to go out for today because he's away, and Mr. X minus 2 has to come in. That's substitution, okay? So that's what we did here, okay? So this Y was replaced with X minus 2, okay? Now why can we do that? Because this is called a Y equals and this is called a Y, okay? Alright, so hopefully that step is clear. That's the most important step. Let's tidy it up from there. So now we just have an equation with one variable. That means it only has x's, this line. And from here on is something that you already know how to do. It's just solving an equation. So the hardest step is the first step. It's the substitution part. So now I can solve it, okay? And solving it means I'm going to put all the x's or variables on one side, on the left side, and I'm going to put all the number things on the right side. So let's see what I've moved. Okay, so we can forget that these brackets are here. I just used those to show you what the substitution was. So I'm going to keep this x here. I'm going to bring this negative x over to this side so it becomes positive. I'm going to keep this x on this side. I'm going to bring this negative 2 to this side so it becomes positive. That was change sides, change signs. Now I'm going to collect like terms. X plus x is 2x, 6 plus 8, 6 plus 2 is 8. And now I'm going to do a swing underneath. The 2 is going to swing underneath, so 8 divided by 2 is 4. Now that I have x, I know what x is. It's very easy to find a y. I can take this x and I can put it into any equation to find y, because they're both y's, right? So I can put 4 in here, or I can put 4 in here. Both will give me the same answer. So I'm going to just choose one, number 1, equation 1. I'm going to sub x equals 4, because that's what the answer we got from here, and I'll substitute it into equation 1. Okay, so notice that substitution means the x is going to come out. Okay, x is going to come out, and the 4 is going to go in place of that. That's what substitution is. So notice I replaced just the 4, and I'm going to tidy this up, and I get 2. So y is equal to 2. So what does that mean? I have to write a conclusion. Therefore, the solution is 4, 2. The solution means where the two lines intersect, and that's our point of intersection. That's our POI. So we just found our POI without sketching. Okay, we can check this by putting 4, 2 into the original equations, and they should work in here and in here. And we can also check this by graphing it on the TI-84 calculators, which we can do at another time. But notice that we have to write this in the correct order. The x coordinate has to go first, and then the y. Okay, you don't want to write 2, 4 because that would be backwards. Okay, so let's look at some more so that we can understand the method clearly, and we'll look at some harder examples. Okay, now these two are a little bit harder because they don't both start with y equals. Okay, and that makes them a little bit harder, but as the title says, notice in the title, here's one of my rules. One equation must have a y equals. They don't both have to, but one must have, okay? So that means we're going to have to change one of these into a y equals. Not both, because that's a waste of time. Okay, so I'm going to change this one. So notice I took the 3x over to the other side. It became a negative 3x, and I kept the 1 on the same side as it was. Now, why did I choose this equation? It's very important to distinguish why I chose this and not this. Okay, this one has a lonely y. It's all by itself already. So notice how easy it was to change it. I do not want to take something like this one and change it to a y equals, because I will end up with fractions. So do not do that. It will be very difficult to solve by substitution. Okay? So let's use our same strategy. Now, you want to take the equation that's a y equals and sub it into the other one. Okay? Because we want this. Let's look at equation 2. Okay, we want this teacher y, Mr. Y, to go out, and we want the new y, which is minus 3x plus 1, to go in. Okay, now this has a little bit more to it, so when you're doing substitution, always make sure you use a bracket. So notice Mr. Y here went out, and this new y came in from equation 1. Okay, it has to be from the other equation. Okay, and there shouldn't be two brackets here. That's an error, so don't worry about that. Just ignore the second bracket. Okay, so that was the hardest step. So hopefully you understood that substitution. Okay, take y equals from the first equation and sub it into where y is in the second equation. Okay, so now we can just tidy up, and we're going to use some BEDMAS. So we have some brackets to expand into. So notice the 5 will multiply into the bracket, into both terms first. So the 2x stays the same. 5 times negative 3x is negative 15x. 5 times 1 is 5, and the 18 stays. Okay, let's do a little rearranging. This 5 has to go to the other side. It will become a negative. Okay, so I just moved one thing. And now I'm going to collect like terms on this side and this side. We get negative 13x here, and we get positive 13 here. So here we're using our integers. And if you have trouble with integers, you can use that integer card that I showed you earlier. And now we're going to divide. This is going to swing underneath. Negative 13 is going to go under the 13, and that gives us negative 1. So we are almost there. Our x is negative 1. We have half of our point of intersection. Now to find the y. Now which would you choose out of these two equations? I would choose this one because this is the same as this, but it's nice and easy to use already, right? I don't want to plug in something here or here. I have to do a lot of rearranging. This is already nice. It says y equals. So I'm going to use this one and plug my negative 1 in here for the x. Let's go ahead and do that. X equals negative 1 into equation 1. Okay, so there it is. I've plugged it in just right into here. Negative 3 times negative 1 plus 1. Do some quick math on that. 3, that becomes 3. Here's our negative times a negative becomes a positive. Plus 1. Our 3 plus 1 is 4. So here I have my point of intersection. So I'm just going to write that same statement again. The solution is negative 1 comma 4. Okay, that is our point of intersection. So you can write it in either way. You can say the solution is, or you can say the point of intersection is, okay? But do make sure that you write a therefore statement and write it as a coordinate point with an x comma y, okay? And then you don't have to write these things. These are just to remind you. Okay, I want to do you can also have one equation being an x equals, and you can substitute for x. Some people do ask that. But traditionally, just to learn it and to be consistent, let's try to stick with y equals. But sometimes you can't get a y by itself, and then you have to resort to an x by itself in one of these two equations, okay? So that's kind of a backup in case we can't find that lonely y, okay? So here's the lonely y that we started with. Okay, looking at a last and more challenging example. Now this one's really difficult, so just follow through here and let's see if we can get through this. I'm going to multiply each term by 6. Okay? The reason I'm multiplying by 6 is because I want to get rid of the denominators. So I chose a number that 3 and 2 would both be able to go into. Okay? So 3 goes into 6 twice, and so it's going to be 2 multiplied by whatever is left on top. 2 will cancel into the 6 3 times, and it'll be 3 times whatever is left on the top, and 6 times 0 is 0. So let me just show you how that works, okay? That's how we got that. Okay, let's do it again for the second one. I can also use 6 to multiply through each term by, because 3 and 6 will go into 6, so I'm going to multiply. I guess we're tidying this up first. Okay, let's just finish up with the first equation. So tidying this up now, I'm going to multiply this into the brackets. So 2 times x plus 2 times 3 minus 3 times y plus, minus 3 times negative 1. Okay, and that gives us 2x plus 6 minus 3y plus 3, and then the 2x is there, the minus 3x, just putting the number parts together, the 6 and the plus 3 gives us a positive 9. So there we have one of our equations all tidied up and ready to go. And that was quite a bit of work. That was 3 steps there. So here we're going to do the same thing to the second equation. I'm going to multiply through by 6. Okay, again, 3 divides into 6 2 times, and then the 2 will have to multiply what's left on top. Here the 6 goes into 6 just once, 1 multiplied by what's on top, and the 6 times 0 is just 0. So that's how we get this, okay? Now, if you're not sure about these first 2 steps, because this is the most challenging type of question you would see, you can ask about that further. Let's tidy up that one. We're going to use some BEDMAS. Okay, so let's notice what happened. 2 times x is 2x. 2 times 6, negative 6 is negative 12, plus a y plus 1. There's nothing to multiply there. Okay, now we're going to tidy this up. The 2x and the y are okay. We're going to put the negative 12 and positive 1 together, which gives us negative 11. Okay, now we've got our two equations. Okay, now which of these two equations, so here I have my first, this was equation 1 and this is equation 2. I want to substitute one of them into the other, and I'm going to look again for lonely y. Where is lonely y? This doesn't have a lonely y. This does have my lonely y. So this is the equation I'm going to rearrange, because remember, one of the equations always has to be starting with y equals. Okay, so I rearranged this. Y equals the 2x went to the other side and the 11 went to the other side, so they changed signs. Okay, finally, we're ready to do the same step we did before. We're going to sub 2 into 1. So notice this is equation 2. It's going to go into 1. Where is it going to go into? This is Mr. Y. That's going to go into this Mr. Y, which is going to come out. And we're going to keep it in brackets when we do that. Okay, so here's equation 2, just copied from here. This y is going to come out, and this y, what y equals, this stuff is going to go in. There it is in the bracket, okay? So this y came out, and this replaced it, or we did substitution here. Okay, so that was the hard part. Now it's just tidying up using BEDMAS. So we're going to multiply out this bracket. Let's see what happened. 2x stayed. Negative 3 times negative 2x is positive 6. Negative 3 times positive 11 is negative 33, and we have a positive 9. These two x's can go together, and the two number parts can go together. So we have this so far. Now this, the number part can go on the other side, so it's going to become positive. We're going to do a swing underneath, and 24 divided by 8, x ends up being 3. We're almost there. We've got half the point of intersection. We just have to plug it into the original equation 1 or 2. Now let's think about this. We're not using that. It looks very messy. This looks very messy. This is still going to mean a lot of moving things around. How about this one? Okay, this equation 2 looks very nice and tidy. It's the y equals. That's probably the best one to use always. So let's take that one. Sub x equals 3 into equation 2, the nice tidied up equation 2. So we have negative 2x plus 11, and this x is going to be replaced with a 3. Like this, we're going to multiply negative 2 times 3 plus 11. It's negative 6 plus 11, which is positive 5. So our solution, therefore, is 3, 5. That's our point of intersection. Okay. Now don't forget, because we don't have the picture anymore, people forget what they're doing or why they're doing this or what this is. This is actually a graph of two lines. Okay, this is our line 1, this is a line, and this is a line, and they're two lines on a graph somewhere, and they have a point of intersection of 3, 5. Okay, just because we don't graph them anymore, don't forget what they look like.